So in this particular lecture we'll be discussing about different types of fits in assembly, the hole basis system and shaft basis system. So to understand the concept of fit, first of all we need to understand the concept of shaft and hole in the assembly. So whenever you are talking about assembly, you have a shaft which is in rod like structure or a solid inserted into a hole like a cavity. So when you assemble the shaft and hole together, we get different types of fits. So before going into those different types of fit, we should understand some basic terminologies. I'll not cover everything. So some basic terminologies like, see, if this is your hole which is being shown with this tolerance zone, this thing is called as tolerance zone, whereas this tolerance zone is denoting the maximum size of the hole and the minimum size of the hole. So maximum diameter or maximum size of the hole is nothing but LMC of the hole, like least material condition, and minimum diameter of the hole is nothing but maximum material condition of the hole. Similarly, when you talk about the shaft, so shaft is having this tolerance zone where again you are showing maximum diameter of the shaft and minimum diameter of the shaft. So here the scenario is quite reverse. Maximum diameter here corresponds to maximum material condition, whereas minimum diameter corresponds to least material condition. So when you assemble this hole and shafts of different sizes together, we get three types of fits. So those three types of fits generally which we get depending upon the actual limits of hole or shafts are clearance, transition and interference fit. These are the three types of fit. So talking about clearance fit, so in clearance fit, hole size will be always greater than the shaft size, resulting in a clearance, little amount of clearance between hole and shaft when they are assembled. For example, if a shaft is rotating inside a bush, we can call that fit as in clearance fit, because shaft is able to rotate inside the clearance and hole is of bigger size. So when you see this clearance fit, you can say this amount between the maximum size of the shaft and minimum size of the hole, the difference, the algebraic difference between minimum size of the hole and maximum size of the shaft is called as minimum clearance, whereas algebraic difference between maximum size of the hole and minimum size of the shaft is called as maximum clearance. So this maximum clearance and minimum clearance you get when you give tolerances on the dimension. So as we have discussed, tolerances are of two types, bilateral and unilateral tolerances. Okay. Similarly, if we discuss about interference fit, so in interference fit, shaft size is marginally bigger than hole size, so that results in an interference fit. So where you see interference fit, the whichever object you see which are very tightly fitted or press fitted, you should say, that is the example of interference fit. So in interference fit, as the shaft size is more than hole size, the object or the shaft has to be pushed or has to be forced inside a hole, which results into an interference fit. So this figure is showing about the interference fit, where you can clearly see the shaft size is marginally bigger than hole size. Okay, so in interference fit there is no gap between the faces and the intersecting material that will occur. So example is the gears which are mounted on shaft in automobile gearbox. So that can be the example of interference fit, where the shaft is of marginally bigger size than that of gear. Okay, so when the gears are fitted by using keyways, that is an example of interference fit. Okay, next is transition fit. we'll discuss. Now the next type of fit is, third type of fit is transition fit. So in transition fit, why we are calling it a transition fit, because it is a kind of adjustable fit where shaft size can be bigger than hole size, or shaft size can be smaller than an hole size. So that means you can swing in between clearance fit and interference fit. So that is what I called as transition fit. So as mentioned here, this is neither a loose nor a tight fit. Like in clearance you will see loose fit, and in interference fit you will see a very tight fit. But in transition fit the scenario is not like that. So object is neither too loose neither too tight. So that is what you call it as transition fit. So the best example that I can give you is when you assemble the body of the pen and the cap of the pen, that is nothing but a transition fit. Okay. So these are the three fits which we generally get. So if you go into the classification of fits, so there are three types of fits when the shaft and hole is assembled. So clearance fit, transition fit, interference fit. So where we see clearance fit, in clearance fit the objects whichever sliding, or the shaft whichever is sliding inside a hole or running inside a hole, or there is a loose running of the hole of the shaft inside the hole, that is the example of clearance fit. So for example, piston cylinder assembly is an example of clearance fit where piston is reciprocating inside the cylinder. So there is a little bit clearance that is in microns, so that is making the motion possible. So that is clearance fit. Okay. In transition fit, in order to assemble the shaft and the hole, you have to push or snug or do some ringing type of action in order to do the transition. So just like in case of the pen and the pen assembly. So that was my example of transition fit. Interference fit. So in interference fit you have to force or press or freeze or tightly assemble the shaft inside the hole, because the shaft size is marginally bigger than hole. So the example of this is the gearbox in which there are shafts and the gears are fixed on a shaft. So that is the example of interference fit. So in GD&T, how you represent fits? So fits are represented by this kind of symbols. So this is the typical representation of fit. I'll just elaborate what this is saying. So whenever you're describing a fit, may it be clearance fit, may it be interference fit, may it be transition fit. Here the slide that we are viewing is regarding clearance fit. So holes are generally represented by capital letters, like from capital A to capital Z, let's say. So that is called as your fundamental deviation. Capital A, capital B, capital C, this thing is called as fundamental deviation. And shafts are represented by small letters from small a to capital A, like that. Okay. So this thing here, H, represents hole with fundamental deviation H. 7 represents your international tolerance grade. There are 18 international tolerance grade. That's different topic, but I'm just giving you the overview of that. /H. So H is nothing but shaft. Small case letter is representing shaft, and the shaft is designed according to IT grade 6. So what this coding gives me? This coding helps me to calculate the tolerances on hole as well as shaft. So what helps me? This fundamental deviation will help me, and this IT grade will help me to calculate that tolerance. So tolerance is not a random value. Like if I say 30 plus minus 0.2. So plus minus 0.2 is not a random value. It is a calculated value. So this 0.2 value is arrived by using different fundamental deviations that we use and different IT grades that we use. So IT grades are like IT1, IT2, 3, 4 to 16, 17, 18. Fundamental deviations are from capital A to capital Z, small a to small z. So like I said, capital letters will represent hole, and small letters will represent shaft. So this particular codes, like here H8, F8, so here H represents hole. That hole is designed according to fundamental deviation H, and its tolerances will be calculated by using IT grade 8. Similarly, here shaft will be designed according to fundamental deviation F, and its tolerances will be calculated by IT grade 8. So there are different IT grade, there are different fundamental deviations. So combination of IT grade and fundamental deviation helps you to calculate tolerance value. So this what you should note. Okay. Similarly, if you go in this particular slide, so this particular slide is talking about interference fit. So here you can see I am representing a hole by using IT grade 8, 7 in some of the example, but fundamental deviation here is H. So that is called as hole basis system. So what is hole basis system? What is shaft basis system? That we will cover later on in the same lecture. So here you can say R, small s, small p, small u, small u. So this is nothing but fundamental deviations used to design shaft. So I hope it is clear to you that capital letter represents hole and small letters represent shaft, whereas these digits, numerical digit that you see 1, 2, 3, they are representing IT grade. So this combination helps you to calculate tolerances. Okay, so just a hint, what is hole basis system and shaft basis system. So in hole basis system, what exactly happen? You keep the hole size constant, okay, and keep varying your shaft size in order to do the assembly. For example, my hole size will be 30 mm, which I'll keep constant, and in order to achieve clearance fit, interference fit, or transition fit, depending upon my requirement, I will keep on varying the shaft size, like 29.99. So if I assemble a shaft of 29.99 with 30 size of hole, I will get clearance fit. Let's say if I change the size of the shaft to 30.01, so shaft size is little bigger than hole, so that will become an interference fit. So the basic idea behind hole basis system is I will keep the hole size constant and I will keep changing the shaft size. Whereas in shaft basis system, what happens? I keep the shaft size constant and keep on changing the hole size. So both have both systems have their own advantages. Like let's say this is hole basis system. So here you can see the hole size is constant and I'm manufacturing 3 shafts of different diameter in order to obtain clearance fit, transition fit, and interference fit. Okay. Whereas if you go in shaft basis system, you can see here the shaft size is constant and according to my requirement I am varying the hole size. So here I am getting clearance, I am getting transition fit, I am getting interference fit. So it is your choice whether you should go for hole basis and shaft basis system, but in general people go for hole basis system. I will tell you why. Because you can drill a hole by using a drilling machine, and in order to manufacture a shaft of different size, you can easily manufacture that shaft of different diameters simply by using lathe machine. You can achieve any diameter you want, so you don't need to change the tooling every time. But if you go with shaft basis system, what will happen? You will manufacture a fixed size of shaft, okay, and in order to manufacture different holes, you need to have different drills with you, which is, so you have to change the drill bit every time on a drilling machine. You should have drill size, or you should have a drill bit of that particular size that you want. So which is economical, it is not so economical. That's why changing hole size I will not prefer. Rather what I'll do, I will keep hole size constant. I will make a drill by using a single drill bit, and I have lathe machine, and by using lathe machine I can manufacture any diameter. different sizes on a single lathe machine by using single cutting tool. That is why I generally, or industry people generally, go with hole basis system. So this is what I mean by hole basis and shaft basis system. Now we have gone through different types of fits. So those are clearance, transition and interference fits, and we have also understood what you mean by hole basis system, shaft basis system, how to write type of fit in symbolic manner. So we'll just go through a simple numerical where we need to identify the type of fit. So you have a hole and shaft assembly whose nominal size is 50. Okay, so hole size is 50 plus 00 plus 0.02. So if I ask you to identify which type of tolerance it is, so it is unilateral tolerance, because hole can be of lower limit 50 and its higher limit is 50.00 0.2. Similarly shaft, so shaft is of 50 but the tolerance is minus 0.08 and minus 0.05. so again it is unilateral tolerance because your size is lesser than 50, whether you go with 0.08 or you go with 0.05. So what you have been asked to calculate? You have been asked to calculate maximum and minimum clearance, because see, from the numerical itself you can understand that hole size will be always bigger than the shaft size. So you should understand that this type of assembly will lead to clearance fit because shaft size will be lesser than 50. Okay, it can be 49.95 or 49.92, whereas hole size can be 50 or 50.02. That's what. So that is why we are asking about maximum minimum clearance. Similarly, what are the tolerances on shaft and hole? So clearly, so the tolerance on hole is, on upper side it is 0.02 and on lower side it is 0. Okay, so on hole, so this was about hole. So tolerance on shaft, so on lower side it is 0.08 and on upper side it is 0.05. Okay, allowance. What is allowance? Allowance is nothing but difference between uppermost size of the component minus lowermost size. So if I ask you to calculate allowance on hole, it will be 50.02 minus 50.00, because 50.02 is your upper limit of the hole and 50 is your lower limit. So 50.02 minus 50 gives you allowance of 0.02. Okay, similarly, what is the allowance on shaft? So what is lower limit of the shaft? It is 50 minus 0.08, so that gives you 49.92. so that's your lower limit. And what's your upper limit? 50 minus 0.05, which gives 49.95. so your limits are varying between, for the shaft, lower limit is 49.92 and upper limit is 49.95. so what's the allowance? Allowance is nothing but upper limit minus lower limit. So 49.95 minus 49.92. so allowance is 0.03 here. Okay, next, what is maximum material condition of hole? So maximum material condition for hole is nothing but minimum diameter. So what is minimum diameter here? 50. So that is your maximum material condition for the hole. And for the shaft, maximum material condition for the shaft, maximum material condition nothing but maximum diameter of the shaft. So what is maximum diameter of the shaft? 49.95. Okay, and what type of fit you are getting? You are getting clearance fit. So here are the answers that I just told you. See, this is the answers that we are getting. Okay, so this is how you solve the problems on these are very simple problems. Designing gauge and designing this tolerance is different part that we are not covering right now, because see, as I told you, this tolerance value is not random value, it is calculated value to calculate this value, we need to take a help of fundamental deviations and IT grades. So that is altogether a different topic. We will cover it in some other lecture. That is different thing altogether. So I was just so this is all about the fits. I hope you understand what type of fit. So fits you get when you are assembling.